Hello, welcome to this video all about mid-air collisions. And well, I want to start today a little bit differently because I was on the internet the other day and I saw this meme here, which made me laugh, but also really got me thinking what what we do and what we can do to avoid crashing into each other, crashing into other aircraft, um, having mid-air collisions. And it really got me thinking, especially if you've been watching the news recently, and you may be watching this in the future, hello to you. But recently there was a mid-air collision in the States involving a Cirrus, so a general aviation aircraft, and a Metroliner, so a small turboprop airliner. And well, it's quite interesting, and there's some points about it that I'm going to come back to over this. But, well, let's look at the real headlines from this. The real headlines right at the beginning are air procs have increased. And when I say air procs, these are essentially near misses. Air procs are when one aircraft comes so close to another one that it thinks it needs to make a report to somebody and say, well, this was a bad thing that happened. And these are really the canaries in the coal mines for us. These are our warnings that there could have been a mid-air collision, and we should learn from these. Think about how to make sure that that doesn't and didn't develop into a collision. The bad news for us in general aviation as well is that we make up the majority of air procs reports and mid-air collisions really as well. And the fact that they're increasing a lot is opening a lot of eyes at the CAA, who are sort of thinking about this a lot more. And I'm going to talk about really what we can do. And the reason this is so important is because, and it probably doesn't need me to spell this out to you, but apart from that really lucky incident in Denver recently, most mid-air collisions are fatal, especially if it's two general aviation aircraft. You'd expect some fatalities. So we're going to look into what we can do about this today. How to reduce that risk. So this is a report from last year's, well, it's 2019 data, but it was published in 2020. It's the most up-to-date one at the moment from the Airprox board, just really showing how civil, or essentially general aviation aircraft versus general aviation aircraft, when you adjust for hours, the amount of airprocs has just increased. And in fact, I don't think this is even adjusted for hours here. This is just the pure number. When you adjust for hours, it's an even steeper gradient. And you can see just behind civil, this thing called SUAS, basically drones. And the big concern there is drones versus big sort of commercial aviation. And that's sort of why that's increased with the use of drones recently. But this is us here, general aviation, civil versus civil. And there's tons of detail in that report. And I really recommend you, if you are interested in this, taking about 10 minutes out to just go and read at least the Airprox magazines, if not diving deeper into the data of the Airprox reports. Now, I've done that, so you don't have to, and looked into all this in a bunch of detail. But the headline is, general aviation airprocs increasing quite a lot. And the things, when you do dive into the data, are that they're almost all in good weather. And we're going to look at why that might be in a bit. That most of the general aviation airprocs are below 3,000 feet. Most in Class G, and that kind of makes sense because that's the airspace we're flying around in most of the time in general aviation. About half of them are sort of near or around an aerodrome. I mean, I suppose you could argue that that makes sense because that's where you're most likely to find aircraft, and where we all come together as aerodromes, that's where you're most likely to see us getting in each other's way. But that does mean we can sort of be more aware, really, around an aerodrome. When you read these reports, what shocks me all the time I read the reports, I really recommend you do get involved in reading them, is a significant number of these reports. At least one of the pilots never saw the other aircraft. And the first thing they know about being involved in a near miss is a phone call or a letter or some sort of notification about it from the Airprox board. We'll come back to why that might be in a bit. And most in and around sort of London, southeast England, Midlands, basically the congested areas of airspace. And I really like this. I'm just going to show you this map. This is using data from the last sort of 20 years of A and B risk airprocs. So that's ones that were pretty dangerous, really. And if I zoom out, you can see how it's pretty much most of them. You can see the thickest amount are sort of in this South and Midlands area. It's really obvious here that clearly this is where a big amount of them happen. That's not to say that you're not at risk in other areas, because you are, but this is clearly the highest concentration of them. And possibly that's because it's the highest concentration of flying, but I think it's probably more to do with the most constrained airspace. And what we were just saying sort of holds true as you zoom in. You can see if I zoom in down here into the south coast, you've got real clusters of airprocs around airfields. So that's Leon Solent down here. This is Goodwood. This is Shoreham. And then this is Lasham, the gliding site, one of the busiest in the UK, if not Europe there. And this map's really good. I'm going to put a link for it in the description, but go have a look around, have a play for it, and you play around with it, and you can really see where the hot spots are. Whenever I fly around this area, squeezing between these two bits of airspace, Southend and City and Stansted, I always come close to an aircraft. It's really busy. There's lots of general aviation aircraft here. If you want to go north-south from some busy parts of the UK to some other busy parts of the UK, this is where you're going to have to go through, really squeeze through there. This is maybe a reminder, if you're thinking of routing around airspace, that you could actually transit. For example, you could transit, instead of going through this gap, go through the Southend Class D area, and maybe then through the Stansted area. Actually, that would be a much safer place to be. So have a play around with that, and you can see where you'd expect these mid-air collisions, where our risk is highest. And I think with the Farnborough airspace being included here, it really sort of puts this big line across southeast England. And I predict in the next few years there'll be more, and I hope we can do stuff to avoid it, but I predict there'll be a lot more airprocs and possibly some mid-air collisions in this area here and this area here, because those are your channels between South and North England, probably cumulatively about to put a figure at it from this position here, probably about 15 miles wide of airspace. So yeah, not a great situation. I think airspace does have a lot to play in squeezing general aviation into little slices, but we don't really have any control of that directly. So let's talk about some other things that we do have control of, and some other stats about it. So we all fly around in Class G airspace, and how are we supposed to avoid those collisions? What do the rules and regs and regulators say about it? Well, they say some basic things like flying the right-hand side of line features. It's one of the earliest rules that ever came in, and actually it's no longer a rule since we abide by, or close to abide by, EASA's single European rules of the air. But essentially says flying the right of a line, so you don't fly into someone else who's also following that line in the other direction. The other thing that's also not mandatory in the UK, but happens quite a lot in Europe, is you're supposed to fly specific VFR cruising levels. Now, we said that most of these airprocs happen below 3,000 feet, and this only applies above 3,000 feet, so it's not really that relevant. And weather minima, so you're not sort of flying close to a cloud and someone comes around the corner, flying around the cloud that you don't see or don't have time to see. So the idea is give a bit of space from clouds, really, and sort of general weather minima, making sure you've got several kilometres visibility so you can see what's going on. I know there's an exception to that, so you can fly in as low as sort of 1,500-1,800 metres. I mean, to me, that's not really good airmanship to be doing that anyway, VFR anyway. So what else? How else are we supposed to do it? Oh yeah, rights of way. So you're supposed to, on the right, in the right. I think that's the rule. So, if you see an aircraft that's on your right, you give way to them. So giving way to other aircraft. And other things, well, there's the sort of priority, remember from your PPL air law days, of, who's giving way to who. And essentially, we give way. We come right at the bottom of this. If you're a flyer-powered general aviation aircraft, essentially you have to give way to everyone. This all relies on everybody seeing each other. It all relies on you seeing the other aircraft so you can give way to them. It all relies on seeing and avoiding other aircraft. And that is pretty much the base principle of avoiding collisions in Class G airspace. We just rely on the eyes. And not really much else is mandatory. But we're going to take a bigger look into this because I'm not convinced our eyes are that good. And let's look at this in a bit more detail. So when you look at the AirProx reports, and especially when they analyse all the data, it turns out that in about half of AirProx, depending how you look at the figures, the see and avoid, the scan method, is looking for other aircraft, is ineffective. It didn't effectively notice the other aircraft. I talked about the recent news of this mid-air collision in Denver between a Cirrus and a Metroliner. And the thing that struck me about it was, there had been some mistakes on the part of maybe air traffic control and the procedures, and probably also the Cirrus. He sort of overshot his turn to final, and it's maybe going too fast, and a few other things like that. But he should have been able to make some mistakes within the system. But the thing that really struck me is that the pilot didn't see the aircraft that he hit. When that pilot called up air traffic control and said, "I've got an emergency," he said, "I've got an engine failure. My engine stopped working." He didn't even know he'd hit anything. He pulled the parachute out, and I think there's some big lessons about how that improves safety a lot, although I think in another video I'd like to look at whether that is true or not. But he declared an emergency, said, "I've had an engine failure." Didn't say anything about a mid-air collision. And so if that is true, we can say that, and if that wasn't him just being confused and panicking and not being sure what to say, and maybe he'd rehearse engine failure lots in his training, but that means he never saw the aircraft he hit. It's this really fascinating report I want to talk about. We're going to come back to it a couple of times in this video. It's done by MIT in Boston. Okay, clever guys. They wrote the code for the space shuttle and Apollo missions, and they're clever guys. They know what's going on. And there's this report by this guy called Jay Andrews, and he ran this experiment in the mid-80s for just evaluating whether TCAS, which was this new idea at the time, was going to be any good. And he found some really interesting things that I want to talk about today. What he did, he got 24 pilots from a real broad selection, from instructors to fairly new PPL holders, to instrument-rated pilots, to commercial pilots. He had real range, really good range. And he got them to fly a cross-country flight with an observer. And what he did was he told them, we're just investigating, what is it? He said to them, your workload management and how you manage your workload. Not telling them he was actually looking at how well they could spot other aircraft. And so they got this other aircraft, this Cessna twin, to fly along and intercept these pilots. I think it was about 3 times on each of these flights. And one of the things this observer said to him was, "Oh, by the way, if you notice any aircraft, point them out to me." And he asked a couple other questions as well. But, he was essentially sat there saying, "Look, if you see any aircraft, point them out to me. I'm going to look at how you manage your workload, and I might ask you the odd question about navigation and stuff like that." So 64 times in total, this aircraft intercepted these pilots. And the pilots spotted the other aircraft 36 times. So, give or take, about half. What that means, and this aircraft was flying close. It was deliberately flying in a position that would be an airprox. They did all the FAA and stuff before. There was no correlations in the results between the levels of experience of the pilots. There was no correlation. The only thing the report did say is that on exceptionally clear days, you think beautiful, gin clear days, we got brilliant visibility, really not a cloud in sight. They said that on those days, the clearness reduced the contrast between the aircraft and the environment behind it, whether it be like a cloudy sky or like a hazy horizon, and made them even harder to spot. But what we can see from this experiment is about half the times the see and avoid principle didn't work on pilots that were deliberately being watched for how they would manage themselves. So clearly there's some limitations on see and avoid, and there's some limitations involved with the eyes. We'll look at some of them in a second, but some of the ones you will probably know is that moving images are way easier for the eye to see. We're born predators. Well, may not feel like it now, but that's where we've evolved from. And so if there's something in your vision that isn't moving, your eye is less likely to notice it, or really your brain is less likely to notice it. The problem for us pilots is that if an aircraft is on a collision course with us, it's probably not, or it won't be, moving in your windscreen. It will just be getting bigger. If it's going to go in front or behind you, or above or below you, it will be moving from your point of view. But if you're going to collide with it, it's not going to be moving. So that produces a real issue for us, because we naturally, as part of being human beings, struggle to see these images that stay still, that don't move. What else is there? There's nothing to focus on. Your eyes just focus, well, just in front of the aircraft. I don't know the exact figure, but essentially a few meters away, your eyes will focus. And you see this when you're driving as well. If you're just on the motorway driving, you should really ideally be looking at the horizon, but you're probably only looking about sort of 10 or 15 meters in front of you. Your eyes just, with nothing to focus on, they just choose a middle distance. There's blind spots as well. In fact, your eye can only see in colour and in detail for really the centre bit of your vision. Everything else, it's either making up or glancing at quickly with that centre bit of your vision, taking in the information, and then your brain is making up what colour it is or detail it is. So actually, in essence, we don't have very good vision. And there's some other visual errors about assumptions from our brain as well we're going to talk about. Aside from how useless our eyes are, the cockpit isn't ever ideally designed. It can never be perfect unless we're flying along in this perfect sphere that's spherical and see-through. And that's not possible because we need wings and engines, and we're going to carry people and things in our aircraft. So it's a real constrained field of view. We're going to look at what the regulations that the FAA say about pilot views out of the window are, and you'll be surprised. In about 15 to 20% of airprocs, depending which report you read and who's doing the stats, one aircraft couldn't see each other because it was unable to, because there was something in the way, a bit of combing, a pillar, a wing, anything. Maybe the aircraft was beneath them and they couldn't see it below the nose, something like this. So it's never going to be possible in all situations. You should note at this point, there seems to be no difference in airprocs between high wing and low wings. There's no real benefit to one or the other. Okay, let's look at some of these in more detail. So I want you to look at this image and just really quickly get your mouse over the toothbrush in this messy bathroom. Find the toothbrush in this messy bathroom. Okay, you've got 5, 4, 3, 2, 1. Great, you found it. It's right in the middle. But then I want you to look again, and I'm going to tell you there's another toothbrush in this bathroom. Can you see it? Yeah, it's gigantic. How did you miss that? The human brain goes immediately for, well, the center of the image, goes to look to see, it's guessing the size of everything around it and has to guess this size. It doesn't see this gigantic toothbrush in this bathroom. And I think this can tell us interesting things about what our brain assumes about what it sees and what it notices. We have all lost something, gone into a room to find something, it's in there and we've not noticed it. Really cool. Next up, let's talk about blind spots a bit. So what I want you to do is keep both your eyes open, but cover one of them with your hand. Maybe let's do your left one. So cover your left hand eye with your hand and look here at the smiley face. And if you can still see the little plane here, move your head backwards or forwards, adjust the position, and you'll notice at quite a lot of points when you're moving your head backwards and forwards, you won't be able to see this plane anymore. So our eyes have really big blind spots that, could be quite dangerous. And this is part of the limitations of our eyes. This is fascinating. So this comes from the FAA certification about what it thinks pilots should be able to see out of its windows. And essentially, it says if you put your eye about here, you should be able to see just straight ahead. You should be able to see 20 degrees up and about 18 degrees down, which actually isn't very much. If you drew a picture from outside a plane about what it could see, 20 degrees up isn't very much, 20 degrees down is very much. And then it's saying your window needs to go to the left. You have to be able to see up to 120 degrees behind you to the left. And there's a similar rule to the right. But what this doesn't say is just must be able to see out the window. It doesn't mean that you can't put a wing here, like you have on a Cessna, so that you can't see in that area there. It doesn't mean anything really much more than that. So there's quite constrained views at the cockpits. We've got to be aware of this as well. So, all right, I've gone on for ages about how bad our eyes and the principles of see and avoid can be. How can we improve see and avoid, which is clearly the main way we avoid collisions? So the first thing is to scan. And you'll have learned this in your PPL training. And really the idea here is that you deliberately stop and focus your eyes at a distant place on the windscreen. This is straight from the Skyway code, this is. So what we're saying is, over this 10 or 15 second period, you just, number one, focus your eyes on a distant point and hold steady so that if anything's moving, your eye will notice it for a good couple of seconds. And then move to a point that's just to the right of that. Hold your eyes there, focusing on the distance for 2 seconds, and you just come around your whole field of view, stopping for every 2 seconds, just focusing on something. And this is really a good method of scanning. I think the easiest one to teach and learn as well, because it kind of makes sense. There's other ones where you do funny different S-turns and stuff like that, but I think this is a really good place to start. And what this does is it means by stopping your eye on a position, you'll notice things that are moving, and by focusing on the distance, your eyes have more chance of seeing it than if they're just sort of focused midway into the distance. So that's one thing we can do. Next thing is to manage workload and distractions so that we can look outside. So often as pilots, we have lots and lots of things to do. So really, when you have a big head-down task, examining a chart for something, why don't you bring that chart up so you can also see outside it a little bit? Why don't you break down those big tasks like changing something on your iPad, or setting a confusing thing on a GPS unit, or changing some radio code or transponder code? Why don't you break that down into smaller tasks? Maybe the first task could just be get my hand on the knob that changes the frequency, and then look back outside again, do a bit of a scan. Then my next task could be change the big number to what it should be, and then look outside another little bit, and then change the little number to what it should be. And you break this big task into the little task, and what this does means you look out way more. 2 benefits. 1, you'll see other traffic more often. Second benefit, you'll find it easier to fly straight and level and hold your attitude if you're looking out more. So good little tip there. What else can we do? Well, the Andrews report gives us a bit more information as well. It says if pilots were alerted to the other aircraft, they were 8 times more likely to see it. So what they did was they ran this experiment twice. The first, as I just described, and the second time with that TCAS unit, essentially alerting the pilots to the aircraft. And they found that if pilots were looking for an aircraft that they were told about, they saw it so much quicker. In fact, their quote was, 1 second of search with the aid of TCAS is effective as 8 seconds of unalerted search. A search just mindlessly looking. So how can we get alerted about traffic? Clearly, it's very, very useful. Well, TCAS not really common on GA aircraft. TSB, great. If you don't know what that is, I'll talk about it in a second. But not really common in the UK. Traffic service. So, I mean, this is great if you can get hold of a traffic service for every flight. It's really good. But the problems are you might not be always in the range of a LARS. The LARS unit might not always have capacity. And for some flights, a traffic service isn't really appropriate if I'm doing lots of aerobatics or general handling or something like that, where I'm going to move unpredictably and at various different levels. Then that's not appropriate for a traffic service. So, I mean, do get a traffic service if you can. What else can we do to improve it? And I think the real big thing that we can do at the moment that's really accessible to us is electronic conspicuity, where essentially we broadcast our position using a little device. It's not very expensive, and other people with a similar device can take in that position and display it on a tablet or something, and that will warn them about you, alert the pilot, so that their see and avoid is way more effective. So much more effective. So as there's plenty available at the moment, and currently the CAA are doing rebates as well, so you can get a bunch of money back. Here's my favourite one, Sky Echo 2. It's ADSB out, I think, is really the future. I know there's other platforms out there, but this is the standardised version, I think, really. You've got to go for the standard that's global if you're going to be involved in aviation. And get yourself a tablet, something like this. Tells you, look at this. This would be beeping at me like mad here, saying there's traffic left 11 o'clock, 2.3 nautical miles away. And I could just look, I'll probably see it really, really quickly. So if you want a bit more detail about how to do this, get yourself a Sky Echo 2. There's currently a CAA rebate, so £250 instead of £500. Get yourself an iPad mini. That is the best size, I think, for flying in general aviation aircraft. Get yourself Sky Demon. It's the best it's the best moving map in the UK. Certainly, I know there are others like 4Flight and stuff that people really love, but this is the best one I've found in the UK, and it will help you stay clear of airspace, and it will alert you of other traffic. It's really useful for flight planning as well, and it's just going to improve your situational awareness. Get yourself a Design for Pilots kneeboard. Don't go mounting that iPad right in the middle of your view, covering up, meaning you can see even less out the window. Don't mount it on the yoke so you can't see any of the instruments. Get it on your kneeboard. This way you will use it as a backup. When it beeps at you, you can just lift open the clipboard, see what it's asking you for. But very much, I think, the best way of integrating it into your workload. And I think really this is the real key to improving see and avoid in the 21st century. I think if you asked people in the public what they thought about flying and how we avoided mid-air collisions, they would be shocked to know that we're not tracked all the time, controlled all the time, and that the main way we avoid other traffic at the moment is looking for them. I think people in the public would find shocking. There are some other things you can do as well, some of them before you even leave the ground. But when you are flying, if possible, climb higher. We saw there's fewer air proxies because there's less traffic above 3,000 feet. A lot of people I fly with seem to just immediately, after the takeoff, subject to airspace, just climb to 2,000 feet and sit there. And the problem is you have everyone just sat at 2,000 feet. So choose a random level. Choose 2,100, 200, 300, 1,900, whatever you want. Choose a random level. That means it's less likely you'll find someone else. Avoid, if possible, or be vigilant at VRPs or good landmarks. This is a real tricky one because as an instructor, when I'm teaching people how to navigate, I constantly tell them to use really brilliant, obvious, good landmarks. Really aids navigation, stops you getting lost. That's going to, getting lost is a bad thing. If you get lost, you're more likely to infringe airspace, that kind of thing. So I don't really want to have to say avoid these good landmarks. But just be aware of them. Be vigilant around them. Make sure your eyes are fully outside while you're over big, obvious landmarks. Not just for other traffic doing navigation, but there's a lot of flight instruction that goes on out there, and instructors really like big landmarks for doing exercise like stalling and steep turns around, because you can just roll out and immediately reorientate yourself. So just be a bit careful. Build up some good situational awareness of what's happening around you. So make sure you've got lots of capacity available to you. You're not super stressed. You haven't got loads of distractions. Listen out on that radio. Talk properly on your radio. A lot of air proxies are quite critical, especially in uncontrolled airspace, about pilots that just switch the radio off, or when they do get to an aerodrome, don't really report their position properly. I've had this before where I've been over somewhere and someone's reported they're over there as well. And I look around and eventually I see them and they're actually like 2 or 3 miles away. So just be really specific with where you are when you do pass your position on the radio. and do pass it often. And yeah, especially around airports. Other ways, clean them windows so that you aren't trying to look through about a million flies to see the other side of it. Your eyes are going to focus on all those little flies, whether you like it or not, and or they're just going to look like other aircraft. So just clean the windows. Have more than one person with you in the cockpit looking out for aircraft, and I think this is a big one. Use your lights. They're not really that expensive, especially at low level, especially in poor visibility or dark days. Switch on that landing light, and it instantly, planes are so much easier to spot when they've got a landing light on. Strobe lights as well, really good if they're fitted. I wish everyone would fit them, really. Check under the wings of high aircraft before turning. You can often lifted a wing and seen an aircraft there, and I'd have turned into it if I hadn't have checked. And same goes for under the nose of an aircraft when you're climbing. And this really, I think, is the big thing. What I was talking about a second ago with electronic conspicuity. Encourage others to get it as well. And there's this report in America where essentially what they did in America was they said, hey, general aviation, what you need to do is pretty much all, although there are some exceptions, need to get ADS-B in and out installed in your aircraft. But what they also said was, what we'll do for you is we'll give you two big things. One, we'll broadcast the weather so you can receive up-to-date weather information on your iPads in your aircraft about what's going on around you. Really, really useful. And second, what they said was also, we will download all that traffic information that we get from you broadcasting your position, and we'll broadcast it back out. We'll also take in information about aircraft that aren't involved and are exempt from doing ADS-B in and out. And if we've got information out, we'll broadcast that out as well. And this is what TIS-B is. And I think this is clearly a great system. No one wants to have to spend more money to put stuff into their aircraft. But if you are going to do that, then what they've done in America is they've given pilots something back for having to do that. I think it's a great system. And there's been reports that basically, if you've got an aircraft with ADS-B in and out, you're about half as likely to have an accident because you've got so much more information. Your situational awareness has increased so much. And I think it's a shame that we're not doing it here, and we're clearly behind the times. So I really think if you want to help to avoid mid-air collisions, you should be encouraging authorities to invest in TIS-B and the information it enables weather broadcasts as well. So write to your MP about this. I know it's old school. Write a letter to the CAA, to AOPA. Become a member of AOPA so that they can lobby this kind of thing on your behalf. And I think that's today's video over really for now. All I really want to say is the principles of avoiding other aircraft are based mainly on see and avoid, a strategy that is not 100% efficient. We've seen it's about 50% efficient. You can make it way more efficient if you know there's an aircraft there. So let's look at more and better ways of letting pilots know that there are other aircraft there. And shout about this from the rooftops, because if you've got ADS-B in and out, you need all the other pilots around to have it as well. I don't know if you can hear that thunder. You can tell why I'm on the ground, not instructing today. Look, thanks very much for watching this video. If you think I've missed any tips for avoiding other aircraft, put it in the comments box below. And here's some further reading for you. I really recommend go and check out the Airprox board mag. This fascinating Australian CAA paper. They always surprise me, the Australian CAA. Really good stuff down there. Limitations on see and avoid. Really recommend you see that. There's a kind of outdated safety sense leaflet from the CAA, but it's worth a look. And I'm always saying, have a look at the Skyway Code. So, hope you found that useful. Hope that will change the way you think about airprox and mid-air collisions. And thanks for watching.